Hi, today we're going to talk about another way to solve quadratic equations by using this thing called the quadratic formula. Okay? First of all, here's the standard form of a quadratic equation again. Notice how things are arranged. Everything's over to one side and set equal to 0. Okay? And we have an x squared term, an x term, and a constant. And notice the number in front of the x squared is called a, the coefficient in front of the x term is b, and then the constant at the end is the letter c. Okay, and right down below here, we have the quadratic formula, okay? And it's x equals the opposite of b, so the opposite of that number, plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, so it's important to know where a, b, and c come from. Okay, but they come from the coefficients in front of the x's and the constant term c. Another thing to notice about the quadratic formula is that it gives us 2 answers, because of the plus and the minus. Negative b plus all that stuff divided by 2a, and negative b minus all of that stuff all over 2a. Okay? What we're going to do next is we're going to take a look at about 4 or 5 examples, practice using the quadratic formula, and we're going to examine the types of answers that we get. And each one of these is different, so it's important to follow along and kind of take note of these. Okay? So we're going to practice a couple of these. And I wrote the quadratic formula over here on the side so we can make reference to it. Okay, the first problem we're going to look at is this. It's x squared minus 8x minus 33 equals 0. Okay? Now, when we do the quadratic formula, again, everything, we have to make sure it's in the right form, standard form, everything's moved over to the other side. Okay? Let's see if we can find out what the solution is here. Let's give it a whirl. Okay? We're going to try x equals. Now before I do that, like I said earlier, it's going to be important to identify a, b, and c. And to start with here, I think it might be very helpful to write down a, b, and c. Okay, now a we said was the number in front of the x squared. I don't see a number out there, but there's actually a number 1. So a is 1, b is negative 8, notice the negative sign, and c is negative 33. Okay? If I put these numbers into my quadratic formula, it's x is the opposite of b, so instead of negative 8, it's going to be positive 8, plus or minus the square root of b squared. And I add these little parentheses here because it's important to make note of that when you square a negative number, it's always going to be positive. So negative 8 squared. And sometimes people don't put parentheses in there, they end up getting a negative number instead of a positive one. By putting that negative sign in parentheses, it always ensures that it's going to be positive. But there's b squared minus 4 times a times c minus 4 times 1 times negative 33 all over 2 times 1, which is 2. Okay, now to start with here, I kind of wrote it all out there. Okay, now before we're going to eventually use our calculators to help us with some things here. Hey, but before we get too gung-ho, let's use our calculators to simplify and evaluate just the stuff under the radical. We're going to come back to that here towards the end. Okay, but just the stuff under the radical. And if you pull out your calculator and you did negative 8 squared minus 4 times 1 times 33, you're going to get 196 over 2 times 1, which is 2. Okay? So we cleaned it up and it looks a lot nicer. Okay? Just the square root of 196. The next thing we're going to want to take a look at every time is let's ask ourselves, is the square root of 196 a nice number? Okay, if you did that on your calculator and did the square root of 196, it would tell you it's 14. So this turns into a nice plain old 14. Okay, and what I have here, scooch this up just a little bit more. What I have is x equals 8 plus or minus 14 all over 2. Okay, and what we really have staring at us there is we have 2 answers staring at us. Okay, there's, I'm going to go like this. When the number under the radical is a perfect square, we should be able to get 2 relatively nice rational numbers, rational answers. But if I did 8 plus 14, that's 22, divided by 2, I get an 11 as an answer. Okay, and then I do the subtraction one. 8 minus 14 is negative 6 over 2, and my other answer is negative 3. Okay? So it works out really nice when this number under the radical is a perfect square. It allows us to get two nice numbers. Okay? So there's one problem with one example using the quadratic formula. We're going to try a couple others here as well. Okay? Here we go. Let's try one of these. Here's the next one I'd like to try. It's negative 3x squared minus 7x plus 2 equals 6. Let's try this. Okay, well, first of all, I look at that and it's not in the proper form. It's not in standard form. I don't have a 0 on one side. The thing that needs to get fixed is that the 6 needs to move over to the other side. Okay, so negative 3x squared minus 7x, and if I minus 6, I get negative 4 equals 0. So there's the equation I'm going to use with my quadratic formula. Okay, and before I get, like I said before, let's identify a, b, and c. If you look out front, a, the number in front of the x squared is negative 3, b is negative 7, and c is negative 4. And it's okay if those coefficients are negatives. That's perfectly fine. Okay? All right, let's try the formula here. X equals the opposite of b. The opposite of negative 7 is positive 7. Plus or minus the square root of negative 7 squared, b squared, minus 4 times negative 3 times negative 4. That's 4 times a times c, all over 2a. Okay? And if I do 2 times a, 2 times negative 3 is negative 6. I oftentimes do that little multiplication. Okay, and like on the last one, let's take a second and let's clean this up a little bit. Let's see if we can grab our calculators. And let's see if we can get a nice number underneath that radical right here. Okay, if you type that in just exactly the way you read it, okay, you should end up with a 1 underneath there, I think. Okay, this should be a positive 1. Okay, and good news for us, if I think about what we did on the last problem, let's look at that number underneath the radical. Is the square root of 1 a nice number? Sure is. The square root of 1 is 1. So this turns into a 1. And what I'm left with here is 7 plus or minus 1 all over negative 6. Okay? Now, like I said, that's a perfect square, we should be able to get two nice rational answers, real solutions, I should say. Okay? Well, I have 7 plus 1, which is 8. Oops, right this way. X could equal 8 over negative 6. And if I reduce my fraction, I get negative 4/3. Okay? And again, we don't want decimals. Let's leave things in fraction form, and we'll see here in a minute in radical form, simplified radical form if we need to. My other answer is going to be 7 minus 1, which is 6 over negative 6. Oops. And that's going to be negative 1. There's my other answer, negative 1. Okay? So, again, the nice thing about this, it was a perfect square. It's simplified, had a nice square root, and it gave us two answers. Even though one's a fraction, that's okay. Just reduce our fraction. Okay? But again, these had two real solutions, two rational solutions. Okay? I've got a third one here. Okay? That we're going to take a look at. It looks like this. X squared minus 6x plus 2 equals 0. This one's going to be a little bit different, possibly. We're going to do the same thing. Okay? Notice it's all equal to 0. If I identify my a, b, and c, a is 1, b negative 6, and c is 2. Make that look a little bit nicer. Okay? I'm going to do my quadratic formula. The opposite of b is going to be positive 6 plus or minus. Now, what some people do, myself included, is can we do this square? And if you want to maybe shorten this up a little bit, could I take b and square it in my head? What's negative 6 squared? Well, it's 36. Minus 4 times 1 times 2. 4ac all over 2 times a. 2 times 1 is 2. And again, if I get out my calculator, and I try and simplify that a little bit, okay, I think I end up with a 28 underneath the radical here. Okay, no, here's something different. 28 is not a perfect square. So now what do we do? Okay, well, kind of like we've done the last couple times here in previous lessons, we must simplify this radical. if we were to use our factor sheets and break apart 28, it has a couple different factors, but the black ones on there are 7 and 4. And the square root of 4 is 2. 7, we can't go any further. So that turns into 7 square roots of 2. Bump that up a bit. So if I simplify one more time, the 28 turns into 7 square roots of 2 all over 2. Oh, I did that backwards, sorry. It turns into 2 square roots of 7 all over 2. There we go. Okay. Now we've seen this before in a previous lesson. We must check our answer here to see, can anything be done with all 3 of the big numbers? It has to go into all 3, and if we look closely at that, I think they can all be divided by 2. If I divide it by 2, that's a 1, that's a 1, and that's a 3. And what I have left is 3 plus or minus 1 square roots of 7 all over 1, which is just that. Okay, now this one, we're not able to combine those two, plus and minus, the plus and the minus, because this is an irrational number. Okay? But it's still a real solution, okay? But it's an irrational. It has 2 irrational ones. And we leave it in this form, simplified radical form. Okay? So sometimes, and again, it all kind of stems from this number under the radical. That kind of makes or breaks, or determines whether or not we're going to have kind of a nice answer or one that's going to have a radical in it. Okay? All right. One more here. This one's a little bit different too. I'm going to have x squared minus 34x plus 289 equals 0. Okay, oh man, this is a big number, 289. Okay, let's try this. Again, if I identify A as 1, B is negative 34, and C is 289. Okay? I'm going to go to my equation. The opposite of B is going to be positive 34 plus or minus B squared minus 4 times 1 times 289. 4 times A times C all over 2A. 1 times 2 is 2. Okay? Now if you take a minute and type that in very carefully, okay, you're going to get kind of a magic number underneath there. This should all turn into a 0. Okay, no, oh, wait a minute, what about that? Is 0 a perfect square? Okay? If you're not sure, check on your calculator. The square root of 0 is 0. This just turns into a 0. So, well, what does that do for my answer then? I have 34 plus or minus 0. Well, 34 plus 0 doesn't do anything, and 34 minus 0 is nothing. So just 34 divided by 2. And if I simplify that, there's just one answer this time. Okay? And it's a real solution, but it has one real solution. Okay? So again, the number under the radical is really, really important. That's kind of the main indicator of what kind of answers we're going to get here. Okay? Sometimes they're perfect squares, sometimes they're not perfect squares, and sometimes we get a special one, something like the number 0. Okay? All right, very nice. Okay? Okay, one more time here. Okay, this one's kind of a special one. Okay, let's see what happens here with this one. What if I get x squared minus 6x plus 13 equals 0? Okay, so it doesn't look any different. It's in standard form. Everything's over to one side. My A is 1, B is negative 6, and C is 13. Okay? Let's use the formula and try to see if we can get an answer here. So x equals the opposite of B, positive 6, plus or minus the square root of B squared. Well, negative 6 squared is 36 again, minus 4 times 1 times 13, all over 2a, and 2 times 1 is 2. Okay, let's grab our calculators, and let's see what we get for a number under the radical this time. Okay, and if you do it this time, 36 minus 4 times 1 times 13, you're going to get negative 16. Now what's the significance of that? Yeah, it's negative. Okay, can we do the square root of a negative number? Mm-hmm. From a previous lesson, we learned that the square root of a negative number is going to incorporate that letter I. Okay, so 6 plus or minus, well, the 16 itself is a perfect square, it's 4. But because it's negative 16, it has an I on it. Okay? All divided by 2. And like we saw in our very first one here, if I look at these coefficients, the big numbers I should say, can they all be simplified? Can something go into all of them? Yeah, a 2 can. If I divide them by 2, that becomes a 1, that becomes a 3, and that becomes a 2. So I end up with 3 plus or minus 2i all over 1, which is just that. Okay, now this also, it still has 2 solutions. Okay, just like all the others did, but they're not real solutions. Because it has an I in it, it's called 2 imaginary solutions. And sometimes the imaginary ones are called complex solutions. Okay, a complex number. Whether you use imaginary or complex doesn't make any difference. I personally use imaginary because it starts with the letter I. And whenever I see an I, it's going to have imaginary solutions. Okay? So it kind of ties all this stuff together that we've done in previous lessons with simplifying radicals, radicals of negative numbers, perfect squares, and things like that. Okay? But that's the real nitty-gritty of how this quadratic formula is working, or how it works. Okay? Well, there's a second part to this lesson here, and this is the last part, and it's actually a little bit easier. It's this thing called the discriminant. Okay? And the discriminant is this stuff that's underneath the radical. It's just the b squared minus 4ac part. And I'm going to write that right over here also. The discriminant is just the b squared minus 4ac. Now notice, yep, it's this stuff right here. Okay. It's not the square root of that though. It's just whatever that is equal to. Okay? And in the previous examples here, like this one here, the discriminant of this one was 196 after we did the b squared minus 4ac. This one, the discriminant was 1. We saw one that had a discriminant of 28, and so on and so forth. Okay, but that's what we're looking for, is the number underneath the radical. Well, what's the significance of the discriminant? What does it do? That's what this second part here says. The discriminant tells us the number and type of roots. In other words, it tells us how many solutions there are, and it tells us what kind of solutions they are. And that's what I have right here. And there are three different things that can happen. Okay, it tells how many solutions and what kind of solutions there are. Okay, the first thing here is if the discriminant is a positive number. Any sort of positive number. It doesn't matter if it's 5, 500, 5,000. As long as it's positive, it's going to have 2 solutions. Okay? And I should say 2 real solutions. Okay? If that discriminant is a perfect square, we can even name it something further. It says 2 rational solutions. If it's not a perfect square, like the square root of 7 I think we saw, then it has 2 irrational solutions. Okay? If the discriminant is a negative number, like we saw in that very last example, negative 16, it has 2 complex or 2 imaginary solutions. And it doesn't matter if it's a big negative number or a small negative number, it's just that it's negative. Okay? And the third and final thing down here is, what if the discriminant is equal to 0? We saw one of those in our previous examples where the number under the radical was a 0. It just had 1 real solution. Okay? So in these next couple examples here, we're going to just pick 2 of them. We're going to find the discriminant, and then we're going to determine how many and what kind of solutions there are. Okay? And there are a couple of them here. Okay? I'd like to do this one right here. Okay? And to get me started here, I'm going to identify A, B, and C. A is negative 5, B is 8, and C is negative 1. If I did my discriminant, if I did b squared minus 4ac, it's going to be 8 squared minus 4 times negative 5 times negative 1. Okay? And this is something you can do simply all right on your calculator if you want to. Okay? 8 squared minus 4 times negative 5 times negative 1. It's going to tell me 44. Okay? Now because it's a positive 44, it's going to have two solutions. Two real solutions. And is 44 a perfect square? No, it's not. So it's actually going to be two irrational real solutions. Okay, we can specify just a tiny bit more. Okay, good. Let's do this guy up here. Let's do one more. A is 1, B is 22, and C is 121. Okay, if I do my B squared minus 4 times 1 times 121, my B squared minus 4AC. Let's try this. If I did 22 squared minus 4 times 1 times 121, I'm going to get 0. This one's kind of a special one. Okay? And if that discriminant is equal to 0, then it just has one real solution. Okay? So finding the discriminant isn't that big of a deal. Okay? A nice little formula, and we're going to use that discriminant to describe the types of solutions. And up here they call the solutions roots. Same thing. Okay? All right. There's one last problem we're going to take a look at, and this is like number 33 in your homework assignment. Okay, and you're going to go camping. Okay, and you're going to go hang some food in a tree so that the bears don't get it. Okay, and you're going to tie the rope to a stick so you have a little more weight to throw it up to the tree. And you're going to throw it up there at 23 feet per second, and it leaves your hand when it's 3 feet off the ground. Okay, well, the question is, will the stick make it over the branch? Okay, so if I was to draw a little picture of what's happening here, okay, here's this, and there's a little branch out here. Okay, and here's you standing down here at the bottom, and you're going to throw a rope up towards the branch. Now there are three things that can happen. Number one, the rope can go up and over the branch. Great, perfect. The second thing that could happen is it could go doink right off the bottom of the branch. And the third thing is you're too wimpy and it doesn't make it up and over the branch. Okay? Well, if it makes it up and over, it has two solutions, doesn't it? Okay? If it hits the bottom of the branch, it technically has one solution. And if it's too wimpy, it doesn't have any solutions. Well, those solutions are kind of describing the discriminant. Okay? So to answer this question, we're going to find the discriminant. Okay, and the discriminant is going to tell us whether it makes it up and over or not. Well, how do we find the discriminant? I have an equation. Well, there's this one right here. Okay, and we've seen bits and pieces of this one, I think, before. And I'll define these different parts here. This right here is the ending height. Okay, T is time, V is its velocity, and H sub 0 is its starting height. Now in this problem here, do they tell us some of those things? How about an ending height? Okay, we want that branch, or that branch is 16 feet high. Okay, we need the rope to get up to at least 16 feet. So that's going to be my ending height, 16. Okay, if I keep going with my equation, negative 16t squared, its velocity, I think right here, we're throwing it up there at 23 feet per second. So 23t. And what's its starting height? Okay, its starting height is 3 feet. When you take this rope and you throw it up there, maybe you're going to do sidearm, but your hand's going to be 3 feet off the ground. That's the starting height. Okay, so that's how we get the numbers into that equation. That's where they come from. Now we want to find its discriminant. Okay, well, before we can find its discriminant, we have to make sure our equation is arranged into standard form. And if I look at my equation here, I don't think I have a 0 on one side, do I? I think this 16 needs to come over to the other side. Plus 23t, and if I subtract that 16, I think I end up with minus 13 over here. This is the equation I can use to find my discriminant. Okay? And rather than writing them all down this time, I'm just going to write A, B, and C like this. I know some people have done that in the past. Okay? And if I do my equation or my little formula for the discriminant, it's going to be equal to b squared minus 4 times negative 16 times negative 13. 4 times a times c. Okay? If I pick up my calculator here, okay, I'm going to do 23 squared minus 4 times negative 16 times negative 13. Okay? And that gives me negative 303. Negative 303. Okay, so to answer the question, if I go back up here to the top, will the stick make it over the branch? Well, the discriminant was a negative number. That tells me there's no solution. That tells me it was too wimpy, didn't make it up and over the branch, didn't work. Okay? So you're going to see one problem like that, similar to that on your homework assignment. Again, it's problem number 33. Okay, but the gist of it is, the whole gist of it is, we're trying to find the discriminant in that problem. Okay? Again, this is called the vertical motion model. We'll fill in numbers. Find that discriminant. If it's a negative number, it doesn't work. If it's 0, that means it hit the bottom of the branch. And best case scenario, we want that discriminant to be a positive number, which means it has 2 solutions, which means it went up and over the branch and crossed it twice. Okay? So 2 things going on today, the quadratic formula and this thing called the discriminant. Thanks for tuning in.